Hello, I'm Cathy Cook. I'm the project coordinator for the school's energy project. This video is to help householders undertake thermal imaging surveys of their own homes.
The school's energy project is pleased to be able to lend out miniature thermal imaging cameras which have been kindly provided by West Solent Solar Cooperative. To find out more about borrowing a camera, go to the school's energy project website www.schoolsenergyproject.org.uk. Click on the Thermal Imaging Survey webpage where you'll find more information and also a request form which you can complete and submit. Part 1 of this video deals with the preliminaries and helps you get started with how to use a thermal imaging camera. Part 2 highlights what to look for as you survey your home. The school's energy project lends out FLIR thermal imaging cameras. On our website we have a page called Thermal Imaging Help with links to the FLIR instruction manuals and videos. Have a look at these resources as they'll tell you how to get started, including switching on the camera, charging it up, and how to navigate the various functions available on the camera. Once you have carefully got the lone camera out of its box and followed the instructions in the downloadable manual, you'll be able to complete the basics of switching on the camera and taking a thermal image. Just a word of warning at this point, whenever you're handling the camera, do take special care not to touch the lens. It's made of a soft material called germanium and has a delicate anti-reflective coating on it which can be easily damaged. And remember that the camera has two lenses, one for capturing the thermal image, which is the germanium lens with the special coating, and also a normal lens for capturing normal visible images. The next question is, what are the images on the camera actually telling us? Well, a thermal imaging camera is seeing infrared rays. But what are infrared rays? Actually, the best example to help us grasp that concept is thinking about the warmth we feel from the sun. And this warmth we feel is as a result of the infrared rays that are coming from the sun. All objects emit infrared rays, but the important thing to remember is that the warmer an object is, the more infrared rays it will be emitting. So let's just think about that for a moment. For infrared rays to reach us from the sun and keep us warm like they do, from 93 million miles away, it means that the sun must be incredibly hot. In fact, it has a temperature of 5,500 degrees C, and the sun is 864,000 miles across. That's 109 times the diameter of the Earth. No wonder it's capable of keeping us warm here on Earth 93 million miles away. Of course, for ordinary objects around us down here on planet Earth, they are much smaller and far less hot than the sun, but they do still emit infrared rays. For example, here's a kettle containing hot water and a hot cup of tea. The hottest part of the images are shown in white and red. That means these areas are emitting the most infrared radiation. Now, a thermal imaging camera has a highly specialised lens, which I've already just mentioned, is made of germanium. This material only lets through infrared rays. It does not see visible light. This ability of the camera lens to see infrared radiation is in complete contrast to our own eyes, which can, of course, only see visible light. Then, behind the lens, the camera detects this infrared radiation coming through and converts it into an image which we can see on the screen. For example, let's look at this thermal image of a saucepan full of very hot water. The camera has been calibrated to show the temperature corresponding to the amount of infrared radiation it's seeing through its lens. Or to put it more simply, certain levels of infrared radiation equate to certain temperatures, and the camera then shows these temperatures as different colours. We've chosen to use the rainbow spectrum for this image, with white and red indicating the hottest part of the image and purple and black the coldest. The camera can also tell us the spot temperature at the crosshairs or in the small circle at the centre of the screen. Look for the spot temperature figure in the top left corner where that blue arrow is. For this hot saucepan, you can see the spot temperature is 90 degrees C. Of course, even cold objects emit infrared radiation, just a lot less. For example, this image shows a tub of ice cream. The coldest part of the picture is the black area. And in the top left-hand corner of the screen, you can see the spot temperature in the centre of the image is minus 10.8 degrees C. And another interesting thing about thermal imaging cameras is that, unlike us human beings, they can see in the dark. I took this image of my son fast asleep in his bed in the dark. He was obviously very warm and cosy under his quilt. We can also get some rather puzzling images using the camera. Look at this. This is a thermal image of some trees. At first glance, you'd almost think the tree trunks were boiling. But if we look carefully at the sidebar, the right-hand side of the screen, where the blue arrow is, we can see that the sidebar is telling us that the warmest part of the image, the white part, is actually only just above freezing at 0.9 degrees C. This image was obviously taken on a very cold day, and actually, in fact, it's a school playground covered with snow. So unlike everything else in the image that was below zero, the trees were not frozen. So their temperature was actually the highest within that particular image. So we need to make sure we don't get fooled by what the camera is showing us. When viewing thermal images, the critical things to remember are, firstly, to check what objects you're actually seeing in the frame, and secondly, to always look at the temperature sidebar to check that you're reading the colours and the temperatures shown correctly. Okay, so you've got to grips with what the camera screen is showing you. Now you'll want to get on and get started with taking some actual thermal images of your home. But to make sure you get the best results from using the camera, you'll need to make sure that the weather conditions outside are suitable. For winter thermal imaging, make sure it's cold outside and the heating's on indoors. So any places where the heat's leaking out will be then obvious. The temperature outside needs to be at least 10 degrees C lower than the indoors temperature. So an outside temperature of 10 degrees C or less is best. And if it's really cold outside, the heat losses will show up even more clearly. However, just a quick point here, the battery in the thermal imaging camera doesn't like extreme cold and will quickly go flat. So if it is below freezing outside, make sure you do limit the time that you are taking thermal images out in the cold. As a general guide, a good time to do thermal imaging of the outside of your home is after sunset, when the temperature outside is dropping and the heat is usually fully on indoors. Sometimes, though, if you're lucky, the weather will be cold and dry and overcast all day. And so if the heating's on inside your home, you can then do thermal imaging at any time. However, there is one absolute no-no with thermal imaging, and that is never try to survey in the rain. Firstly, this is bad for the camera. Secondly, the rain confuses the thermal images. And thirdly, the outside of your home will be getting wet, so it'll be extremely difficult to correctly identify any problem areas where you've got heat being lost or where there's moisture ingress. So you should wait until the outside of the building is properly dried off, that'd be usually the next day, before you try doing your thermal imaging survey. It's also best to avoid thermal imaging on a sunny day, or even if there's just been some sunny intervals, as the sun will be warming up the outside of your building and you won't be able to see where the heat's leaking out of your home. Finally, for this video, we're going to cover those pitfalls that we need to be mindful of when we're using the thermal imaging camera for surveying our homes. First, make sure windows and doors are closed, and if you've had to shut some before starting, wait 15 to 20 minutes to let the temperature settle before you take any thermal images of them. That way you'll be able to accurately see whether there's any heat leaking out around them. Next, keep people and animals out of your image, and that includes your own reflection. Human beings and other warm-blooded creatures, as you can see, will show up strongly in thermal images in the winter because they're a lot warmer than a house or a building. This isn't helpful when we're trying to track down a window or a door that's leaking heat. It's also best, if you can, to avoid getting the sky in the image, because if the sky is clear, we're actually seeing out into space and it's incredibly cold out there. The thermal imaging camera will register these cold temperatures, and this will tend to mask the finer temperature differences on a building that we're surveying, which will make it harder to identify small-scale heat leaks around windows and doors. Finally, be careful when thermal imaging shiny reflective surfaces, such as glass windows or slate roofs, as most of the time you'll simply be taking a thermal image of whatever's been reflected off them. For a slate roof, it will probably be the temperature of the sky you're seeing reflected off the roof, rather than the actual temperature of the roof itself. With windows, the thermal imaging camera cannot see through the glass, so it will only be picking up the infrared rays that are reflected off the glass, as in this image where the glass is showing the reflection of surrounding buildings, some trees and the sky. So the best approach is to try to get a good distance away so that any reflections are less of an issue and the camera is more likely to be showing the general temperature of the window or the roof and of any leaks. Then if you do identify any issues, especially with windows, you can get up close and check them out. And here's a useful trick. Try viewing the window obliquely, as that will mean that your reflection will be excluded from the image. So now we've covered all the preliminaries, let's do a quick recap. First of all, to get yourself started, you're going to find out from the downloadable instruction manual how to turn the camera on and how to take thermal images. We've also learned about spot temperature, which is registered at the crosshairs or the circle in the middle of the camera screen, and that this temperature is shown in the top left-hand corner of the screen. And you've also seen the temperature sidebar, which shows you the temperature range within that thermal image that you're looking at. We've also learned what are the best weather conditions for winter thermal imaging. First, we need to make sure that the heating is on indoors and that there's more than a 10 degrees C difference between the temperature inside your home and the outside air temperature. Dry, cold and dull weather conditions are perfect and mean that you can survey at any time of the day, or you can survey on a cold evening after dark. And we've learned that we never use a thermal imaging camera in the rain. And we've also found out that we should avoid sunny days, as these warm up the exterior of our home and prevent us spotting where the heat is leaking out. Lastly, we talked about the pitfalls to avoid when taking a thermal image. Make sure windows and doors have been closed and the temperatures have been allowed to settle. Keep warm things like humans and animals out of the image. Avoid getting the sky in the image because it's very cold. And take special care with reflective surfaces like slate roofs and windows. So, thank you very much for watching this video. We look forward to seeing you in part 2, when we'll be covering the exciting activity of actually doing some real thermal imaging and highlighting the things that you need to look out for when you're surveying your home. Bye for now.